There are places in the universe where the rules of reality break down, where time slows, space bends, and even light itself cannot escape. These are the darkest, most enigmatic objects in the cosmos. They are black holes. For centuries, they were the realm of science fiction. Today, they are one of the greatest frontiers in astrophysics. What are they? How do they form? And could they hold the secrets to time travel, or even the fate of the universe itself? In this journey, we will dive deep into the science behind black holes, from their anatomy and formation to the mind-bending effects they have on time and space. We'll explore the terrifying process of falling in and the groundbreaking theories that suggest they might one day evaporate. But we won't stop there. We'll explore whether black holes could be gateways to other universes and how cutting-edge telescopes like the James Webb and the Event Horizon Telescope are bringing us closer than ever to understanding them. Prepare to venture into the unknown. Welcome to 30 Minutes of Black Holes Explained. If you're fascinated by the universe's greatest mysteries, make sure to like, subscribe, and join us on this journey through the cosmos.
Imagine something so powerful that nothing, not even light, can escape its grasp. A force so extreme that it bends the fabric of reality itself. This is the world of black holes. Perhaps the strangest objects in the universe, but what exactly are they? And if they swallow everything, how do we even know they exist? A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. But how do they form? Most black holes begin their lives as massive stars. When a star reaches the end of its life, it undergoes a supernova explosion. If the remaining core is heavy enough, it collapses under its own gravity, forming an incredibly dense object with a gravitational pull so strong that it creates what scientists call a singularity. At the center of a black hole lies the singularity, a point of infinite density where the laws of physics as we understand them break down completely. Surrounding the singularity is the event horizon. This is the boundary where escape becomes impossible. Imagine a powerful waterfall. Once you pass the point of no return, you can't swim back against the current. In the same way, once something crosses the event horizon, it's lost forever. Interestingly, if you were watching an object fall into a black hole from a safe distance, it would appear to slow down and never actually cross the event horizon. This is because of an effect called gravitational time dilation, where time stretches due to intense gravity. If black holes absorb all light, how do we even know they exist? Scientists detect black holes in several ways. One method is by observing their gravitational effects on nearby stars and gas clouds. If a star is orbiting an invisible mass at incredible speeds, it's likely a black hole. Another method is observing something called an accretion disk. When a black hole pulls in surrounding gas and dust, this material heats up and glows brightly before crossing the event horizon. This is what allows telescopes to capture indirect images of black holes. Not all black holes are the same. Scientists categorize them into three main types. Stellar black holes. Formed from collapsing stars, these are the most common. Supermassive black holes, millions to billions of times the mass of the Sun. They sit at the center of galaxies, including our own Milky Way. Primordial black holes, hypothetical remnants from the early universe, potentially smaller than an atom but just as powerful. Now comes the big question: what happens if you fall into a black hole? The answer depends on the type of black hole. If you're falling into a stellar black hole, the difference in gravitational pull between your head and feet would be so extreme that you'd be stretched into a thin strand, an effect known as spaghettification. However, if you fell into a supermassive black hole, you might actually cross the event horizon without immediate harm. But what happens next is a mystery. Do you hit the singularity, or do you enter another reality? The more we study black holes, the more questions arise. Could black holes be wormholes to other universes? Can we extract energy from them? The Event Horizon Telescope recently gave us the first direct image of a black hole, but this is just the beginning. In the future, new telescopes and space missions might uncover even deeper mysteries about these cosmic giants. Until then, black holes remain one of the most mind-blowing enigmas in the universe. If you could safely visit a black hole, would you? Why or why not? Let me know in the comments. If you enjoyed this deep dive into black holes, don't forget to hit like and subscribe for more mind-expanding space content. Every star has a life cycle. For billions of years it shines, burns fuel, and creates the very elements that make up our universe. But what happens when a star reaches the end of its life? Some stars simply fade away, but the most massive ones die in spectacular explosions, leaving behind something so dense, so powerful that not even light can escape: a black hole. It all begins in a cosmic nursery. Giant clouds of gas and dust called nebulae. Gravity pulls the material together, igniting nuclear fusion, and a star is born. For millions to billions of years, a star remains in what's called the main sequence phase, where it fuses hydrogen into helium in a delicate balance between gravity pulling inward and pressure pushing outward. Our sun, for example, will eventually become a red giant and then a white dwarf. But for stars more than 8 times the mass of the sun, their story ends much more dramatically. When a massive star runs out of fuel, fusion slows down and gravity wins. The outer layers collapse inward, triggering an explosion so powerful it outshines an entire galaxy. This event is called a supernova, and it's one of the most violent events in the universe. Supernovae don't just destroy stars, they create. These explosions forge heavy elements like gold and uranium, seeding the cosmos with the building blocks of planets and even life itself. But what happens to the core of the star? If it's between 1.4 and 3 times the mass of the sun, it collapses into a neutron star, an ultra-dense object made entirely of neutrons. But if the core is even heavier, it keeps collapsing, crushing everything into a single point of infinite density, a singularity. This marks the birth of a black hole. At this stage, nothing can escape. Gravity is so strong that space and time are stretched to their limits. The black hole is now fully formed, hidden behind an invisible boundary known as the event horizon, the point of no return. So should we worry about our own sun turning into a black hole? Thankfully, no. The sun is far too small for that. Instead, in about 5 billion years, it will expand into a red giant, shed its outer layers, and leave behind a glowing white dwarf. No explosions, no black holes, just a slow fade into cosmic history. Scientists are still unlocking the secrets of black hole formation. Observatories like the James Webb Space Telescope and the Event Horizon Telescope are looking deeper into the cosmos than ever before, searching for newborn black holes and the remnants of ancient supernovae. By understanding how black holes are born, we get closer to unraveling their true nature. And who knows, maybe one day we'll witness the birth of a brand new black hole in real time. What do you think happens to time inside a collapsing star? Let me know in the comments. If you're fascinated by the life and death of stars, don't forget to hit like and subscribe for more deep dives into the cosmos. Imagine piloting a spaceship toward the most mysterious place in the universe, the edge of a black hole. As you get closer, something strange happens. Time slows down, light warps around you, and once you reach a certain boundary, there's no turning back. This is the event horizon, the ultimate point of no return. So what exactly is the event horizon? It's the boundary surrounding a black hole where the escape velocity exceeds the speed of light. Once anything, matter, light, or even information crosses this invisible line, it's lost to the universe forever. For example, on Earth, rockets need to travel at 11.2 kilometers per second to escape gravity. But a black hole's gravity is so intense that even light, traveling at 300,000 kilometers per second, isn't fast enough to break free. But what happens when you get close? Thanks to Einstein's theory of relativity, time and space don't behave the way we expect. From an outside observer's perspective, you appear to slow down as you near the event horizon, eventually freezing in place. But for you, time flows normally as you plunge inward. This effect is called gravitational time dilation. The stronger the gravity, the slower time moves. Near a black hole, seconds for you could be years or even centuries for the outside universe. Now let's talk about one of the strangest effects, spaghettification. If you fell feet first into a black hole, gravity at your feet would be exponentially stronger than at your head. This difference in force stretches you like spaghetti, tearing apart atoms, molecules, and eventually ripping you down to fundamental particles. But spaghettification only happens in stellar mass black holes. In a supermassive black hole like the one in the center of our galaxy, the event horizon is so large that you could cross it without even noticing, at least at first. If black holes trap light, how do we see them? The answer is indirect detection. We can observe how black holes affect their surroundings. In 2019, scientists used the Event Horizon Telescope to capture the first ever image of a black hole's shadow, an orange ring of superheated gas swirling around an invisible core. What happens beyond the event horizon is still one of the biggest mysteries in physics. Does all matter get crushed into an infinitely dense singularity? Could black holes be gateways to other dimensions? Some theories suggest that information isn't lost inside black holes, but somehow encoded in the event horizon itself. One thing is certain: black holes challenge our understanding of the universe. As we build more advanced telescopes, we may soon uncover new physics hiding beyond the event horizon. Do you think the event horizon hides secrets we have yet to discover? Let me know your thoughts. If you love mind-bending space mysteries, don't forget to like and subscribe for more cosmic deep dives. Imagine falling toward a black hole. At first everything seems normal, but as you drift closer, light stretches and space itself bends. You cross the event horizon, no turning back. What happens next? Do you get crushed, transported, or do the laws of physics themselves cease to exist? Once you cross the event horizon, even light can't escape. But what's beyond it? The truth is, we don't know for sure. Einstein's general theory of relativity tells us that gravity becomes so strong that space-time bends infinitely, leading to a singularity, a place where density is infinite and the laws of physics break down. Does that mean everything is crushed into an infinitely small point? Maybe. Or maybe something even stranger happens. In smaller black holes, you wouldn't even make it past the event horizon. Gravity would pull your feet much harder than your head, stretching you like spaghetti until your atoms are torn apart. But in a supermassive black hole, the event horizon is so large that you could pass through without noticing, at least for a while. If you survive the journey, you'll eventually reach the singularity, the center of the black hole, where gravity is infinite. But here's the problem. Einstein's equations stop making sense at this point. We need quantum mechanics to understand what really happens inside. Quantum physics suggests that information can't just disappear. So what happens to the matter that falls in? Some theories suggest that the singularity might not even exist in the way we imagine. One radical theory suggests that black holes could be gateways to other parts of the universe, or even other universes entirely. Some physicists propose that when a black hole forms, it creates a baby universe on the other side. Some even speculate that our own universe was born from a black hole in another reality. Stephen Hawking discovered something shocking. Black holes slowly evaporate over time through Hawking radiation. But this creates a paradox. If black holes vanish, does all the information inside them disappear forever? That would break the rules of quantum mechanics. Some scientists think that the information is somehow preserved, maybe even stored in the event horizon itself. If that's true, it could change everything we know about physics. What do you think happens inside a black hole? Do we get crushed, transported, or something else? If you love space mysteries, hit like and subscribe for more deep dives into the unknown. Imagine you're floating in space, staring at the massive void of a black hole. Suddenly, gravity pulls you in. At first, nothing feels strange, but as you get closer, something terrifying starts to happen. Your body begins to stretch. Your feet feel like they're falling faster than your head. What's happening to you? Welcome to Spaghettification, the ultimate cosmic torture. So why does this happen? The closer you get to a black hole, the stronger gravity becomes. But here's the catch. Gravity isn't the same at every point. If you fall in feet first, the pull on your feet is much stronger than on your head. This difference in gravity is called a tidal force, and it's what stretches you like a noodle. Would this hurt? At first, no. The process actually starts slow. If you were falling into a supermassive black hole like Sagittarius A** at the center of our galaxy, you wouldn't even notice it at first. The stretching would happen gradually, and you might even survive for a while past the event horizon. Let's say you have friends in a spaceship nearby. Could they rescue you? Unfortunately, no. The moment you pass the event horizon, you're doomed. Even light itself can't escape, so any rescue attempt is impossible. So what happens next? If Einstein's general relativity is correct, you'll eventually reach the singularity, a single point of infinite density where the laws of physics break down. Everything you are, every atom in your body would be compressed into something unimaginably small. But what if that's not the end? Some physicists think that the singularity isn't really a point of infinite density, but instead a gateway to another part of the universe, or even a different reality entirely. What would you do if you found yourself falling into a black hole? Do you think it would be a quick end, or could there be something beyond? If you love space mysteries, hit like and subscribe for more deep dives into the unknown. We are living in a golden age of black hole research. For the first time, we've seen a black hole. We're detecting gravitational waves, and new space missions are pushing the limits of what we know. But what's next? Could black holes become energy sources? Could we create them in a lab? Let's take a look at the future of black hole science. Before we look at the future, let's see how we study black holes today. Scientists use powerful tools like the Event Horizon Telescope to capture images of black holes. The James Webb Space Telescope is now helping us see how black holes shape galaxies. And the LIGO Observatory detects gravitational waves, which are ripples in space-time created when black holes collide. These discoveries have confirmed Einstein's theories and opened new questions about black holes. But now, we're taking things to the next level. In the next decade, several new missions will revolutionize our understanding of black holes. One of the most exciting is LISA, a space-based gravitational wave detector launching in the 2030s. Unlike LIGO, which is based on Earth, LISA will be able to detect supermassive black hole mergers from across the universe. The Event Horizon Telescope is also getting an upgrade, allowing us to capture even clearer images of black holes, revealing details we've never seen before. Now let's get into the wild ideas. Could we use black holes as energy sources? Some scientists believe it might be possible. Black holes give off enormous energy through a process called Hawking radiation and their accretion disks, which heat up to millions of degrees. One theoretical idea is the Penrose process, which suggests we could extract energy from a black hole by using its spinning motion. Another concept is a Dyson sphere built around a black hole to capture its radiation. It sounds like science fiction, but in the distant future, this could be how advanced civilizations power their technology. Here's a mind-blowing idea. What if we could create black holes in a lab? Some scientists believe that the Large Hadron Collider, or LHC, could theoretically produce tiny black holes for a fraction of a second. These wouldn't be dangerous. They'd evaporate almost instantly due to Hawking radiation. Studying these miniature black holes could help us unlock the mysteries of quantum gravity and maybe even figure out if black holes connect to other universes. Even with all these breakthroughs, we still don't fully understand black holes. What happens at the singularity? Do black holes destroy information, or is it somehow preserved? Could they be gateways to other dimensions? With new telescopes, powerful simulations, and future missions, we are on the verge of solving some of the biggest questions in the universe. One thing is certain: the future of black hole research is going to change everything we know about reality. What do you think is the biggest mystery about black holes? Let us know in the comments. If you love exploring the cosmos, hit that like button and subscribe for more deep space discoveries. We know that nothing can escape a black hole once it crosses the event horizon, but what if that's only half the story? Could black holes actually be gateways to other parts of the universe, or even entirely new dimensions? Today we explore one of the most mind-bending theories in physics, the idea that black holes might actually be wormholes. Back in 1935, physicists Albert Einstein and Nathan Rosen proposed something incredible, an idea now known as the Einstein-Rosen bridge. According to their equations, black holes might not just be cosmic dead ends, but rather they could be connected to a twin structure on the other side. This bridge between 2 points in space is what we now call a wormhole. Imagine you're in a spaceship traveling toward a black hole. Instead of being crushed into oblivion, you might pass through a tunnel in space-time and emerge somewhere completely new, maybe even in another galaxy, or another universe altogether. But there's a problem. According to classical physics, wormholes are highly unstable. They would collapse before anything could pass through. However, some theories suggest that exotic matter, a mysterious type of matter with negative energy, could keep a wormhole open and traversable. This means that if black holes really are wormholes, something would need to hold them open. Otherwise, they'd collapse the moment you enter. Some physicists believe quantum mechanics might provide the key to keeping them stable. So, let's say you're brave enough to fall into a black hole. What happens next? Most physicists believe you'd be spaghettified, stretched into oblivion by immense gravity. But some models suggest that under the right conditions, you could survive and emerge on the other side. If that's true, where would you end up? Some theories suggest wormholes could act like shortcuts through space, allowing for near-instant travel across vast cosmic distances. Others propose something even wilder. Black holes could be gateways to parallel universes. Here's where things get really crazy. Some scientists believe that black holes aren't just connected to other parts of the universe, but that each black hole might give birth to an entirely new universe. According to this theory, called the cosmic natural selection hypothesis, our own universe may have formed from a black hole in another universe. If that's true, then every time a black hole forms, it might be seeding a brand new universe on the other side. So, could black holes truly be natural portals for interstellar travel? Right now, we don't know, but as our understanding of quantum physics and gravity improves, we may one day unlock the true nature of black holes, and maybe, just maybe, find a way to safely pass through one. Would you dare to enter a black hole if it meant discovering a new universe? Let me know in the comments. If you love space mysteries, don't forget to hit like and subscribe. We've got more mind-bending space explorations coming your way. What if I told you that time doesn't pass the same for everyone? And what if I told you that near a black hole, time actually slows down, allowing someone to age just 1 year while centuries pass for the rest of the universe? This isn't science fiction, it's gravitational time dilation, and today we're diving into one of the strangest effects of black holes. To understand why black holes slow time, we need to talk about Einstein's theory of general relativity. Einstein showed that gravity doesn't just pull on objects, it also affects time itself. The stronger the gravitational pull, the more time slows down for someone near the source of that gravity. This effect is called gravitational time dilation, and we've actually measured it here on Earth. If you live in a skyscraper, time moves slightly faster for you than for someone on the ground, because you're further from Earth's gravity. Now let's take this to the extreme. Imagine an astronaut orbiting a supermassive black hole, like the one at the center of our galaxy, Sagittarius A. Because of its intense gravity, 1 year for the astronaut might equal thousands of years for someone far away. The closer they orbit, the slower time moves for them. In theory, if you could safely orbit a black hole for a while and then return to Earth, you'd effectively travel into the future because time would have passed much slower for you. You might remember this from the movie Interstellar. The astronauts visit a planet orbiting a massive black hole, and due to gravitational time dilation, 1 hour on the planet equals 7 years in normal space. When they return to their ship, their colleague has aged decades while they've only aged a few hours. This is a real effect, and while we haven't sent astronauts near a black hole, we have observed time dilation on smaller scales, like on GPS satellites orbiting Earth. So could we use black holes for time travel? Theoretically, yes, but with some major challenges. First, getting close enough to a black hole without being pulled in is nearly impossible. Second, the tidal forces, known as spaghettification, would tear anything apart long before reaching the event horizon. However, if we could find a way to orbit a supermassive black hole at just the right distance, we could potentially experience time much slower than the rest of the universe. A real-life time machine. Right now, we don't have the technology to send a human near a black hole, but future civilizations might. If we ever find a way to harness time dilation, black holes could be the ultimate one-way ticket into the future. So what do you think? Could black holes be used as a real time machine? Drop your thoughts in the comments. If you love space mysteries, don't forget to hit like and subscribe. More mind-bending videos are coming soon. We are living in a golden age of black hole research. For the first time, we've seen a black hole. We're detecting gravitational waves, and new space missions are pushing the limits of what we know. But what's next? Could black holes become energy sources? Could we create them in a lab? Let's take a look at the future of black hole science. Before we look at the future, let's see how we study black holes today. Scientists use powerful tools like the Event Horizon Telescope to capture images of black holes. The James Webb Space Telescope is now helping us see how black holes shape galaxies, and the LIGO Observatory detects gravitational waves, which are ripples in space-time created when black holes collide. These discoveries have confirmed Einstein's theories and opened new questions about black holes. But now, we're taking things to the next level. In the next decade, several new missions will revolutionize our understanding of black holes. One of the most exciting is LISA, a space-based gravitational wave detector launching in the 2030s. Unlike LIGO, which is based on Earth, LISA will be able to detect supermassive black hole mergers from across the universe. The Event Horizon Telescope is also getting an upgrade, allowing us to capture even clearer images of black holes, revealing details we've never seen before. Now let's get into the wild ideas. Could we use black holes as energy sources? Some scientists believe it might be possible. Black holes give off enormous energy through a process called Hawking radiation and their accretion disks, which heat up to millions of degrees. One theoretical idea is the Penrose process, which suggests we could extract energy from a black hole by using its spinning motion. Another concept is a Dyson sphere built around a black hole to capture its radiation. It sounds like science fiction, but in the distant future, this could be how advanced civilizations power their technology. Here's a mind-blowing idea. What if we could create black holes in a lab? Some scientists believe that the Large Hadron Collider, or LHC, could theoretically produce tiny black holes for a fraction of a second. These wouldn't be dangerous, they'd evaporate almost instantly due to Hawking radiation. Studying these miniature black holes could help us unlock the mysteries of quantum gravity, and maybe even figure out if black holes connect to other universes. Even with all these breakthroughs, we still don't fully understand black holes. What happens at the singularity? Do black holes destroy information, or is it somehow preserved? Could they be gateways to other dimensions? With new telescopes, powerful simulations, and future missions, we are on the verge of solving some of the biggest questions in the universe. One thing is certain: the future of black hole research is going to change everything we know about reality. What do you think is the biggest mystery about black holes? Let us know in the comments. If you love exploring the cosmos, hit that like button and subscribe for more deep space discoveries.